Hello and welcome to part B of the linked list portion. So if I can kind of recap, we were basically moving the current to end. In our case, we didn't have a node, or we didn't have large elements, so it was just a matter of, okay, there's nowhere to move. Then the point where it says current pointer at next equals new record pointer. What that looks like, here's my current pointer. The next used to equal null. Now what happens is the current pointer at next now points to whatever the new record pointer is, which is up here. So now I've created the elements of here's my head, it points to my first node, which is my next, that points to the next node. Now what happens is when we go back through, current pointer is still going to be pointing there conceptually, but basically it goes away. And now what I have is the beginnings of a linked list. So what I'm going to do is I'm going to move some of this over to give you a better idea of what goes on. So let's say I've got my first element in there. There's my head pointer. And here's my second element. And here we are. I'm going to make the pointer a bit smaller here to make it a little bit easier to work with. So here's my pointer, and here's my next. And here I am right there. And in order to help us out conceptually, what we're going to do is I'm going to create I'm going to move this next is equal to null kind of over here. Alright, so I've got the beginnings of a linked list. Here's my head pointer to my data, to my next node, and here we go. So now let's say it goes back through, and I go back, once this is done, I'm done with my add node code. I then go back to my main program, and it says while get county data name population, meaning while this is true, because my get data has a choice to say keep data. So if I go through and I enter in data, great. If not, I push keep data to 0. So if keep data returns as 1, it's going to keep looping through. So the very first thing it does is it goes to my add node. So I go down to my add node. It says I create a county node new record pointer. So once again, I'm over here. Here's my new record pointer, right? New record pointer, and it points to right here. Now you'll notice it says, okay, so then I copy data into it. So str copy county name, and new record pointer population equals population. So now what I've done is I've copied data into it. So here's my data that I copied into it. And then the next thing it does is it says new record pointer at next equals null. So new record pointer at next, it accesses the next element, and then it actually creates a null part to it. So what I'm going to go ahead and do is I'm going to grab this right here, copy it, paste it, and then I'm going to come out. There's my null. So once again, now I have a linked list right here. Here's my head pointer, points to my first null. Here's my next pointer, point to this node. Here's my next pointer, point to null. Then I have in its own particular elements right here where my new record pointer points to data, which then again points to null, and it's completely separate from this right here. So after I create my new record pointer, I do move current to end. Now once again we go back to move current to end. Current pointer equals head pointer. So I come up here and I create a current pointer that points to what head pointer points to. So here's my current pointer, and my current pointer points to what head points to. So I come along, current pointer and head are now pointing to the exact same location. Then what it says is, it says current pointer equals head pointer, we just did that, while current pointer and next is not equal to null. So we come along here, does current pointer at next, so here's my next, not equal to null. That's true, it doesn't equal to null. Then what I do is I say current pointer equals current pointer at next. Now that we have elements in our list, I have current pointer equals current pointer at next. So now what happens is current pointer will now point to the same node that the next points to. Now we haven't written next on here, but here's the next element here. And here's my part right here that is also next. Now, and since we're doing this on all of them, here's next right here. So in each one of these cases, this next points to this node, this next points to this null. And my new record pointer points to data, and then next points to null. So current pointer has now followed next to what it points to, which is this one right here. So I continue my loop that says while current pointer at next does not equal to null. So I come along here. Does current pointer at next equal to null? Well, yeah, current pointer at next does equal to null, so I return out of this. I return out of this code. So I'm done with this, and now I return back here. There's my move current to end. Alright, so you've got your move current to end, right? We just finished that. Now it says current pointer at next equals new record pointer. So what goes on right here, here's my current pointer. My next is now equal to null. Well, I want the next to now point to what new record pointer did. Now, because of my limitations here, it might be kind of screwy, but let's delete this bad boy here. And then I have this element. Let me see if I can find... Nope. Okay. See if this will actually work. So my next is actually going to point up here. So now I have a situation where current pointer at next equals what new record pointer points to. And as soon as that happens, basically my current pointer is going to keep floating around pointing to this one. My new record pointer is going to keep floating around pointing to this one until I create another node. At the point in time when I create another node, I rearrange current pointer. You know, I'm going to put current pointer is equal to what head is, and then I'm going to make new record pointer equal to another slice of data somewhere, so that goes away up here. And then I've got a new record. Here's my new element here, and then this points here, and I've got a new null, right? But my process is going to continue to repeat itself. Notice now I have all of these elements all chained together through this linked list that ends in null. So then I move current to end, right? So I'm now in my move current to end code. So it does, is current pointer at next equal to null? No, it's not. So I'm going to grab it and I'm going to put current pointer at next equals, well, current pointer equals current pointer at next. So current pointer is going to point here. And then it says, is current pointer at next equal to null? No. So then it says, once again, current pointer equals current pointer at next. So it follows this, so it points up here. So it points right here. That's going to be difficult. And then at the point in time when the current pointer points here, I'm going to try to make it squishy. It's kind of squishy. Okay. So when my current pointer now, make it a little bit more squishy. So now when my current pointer points here, it says, is current pointer at next equal to null? Why, yes indeedy it is. So then what I do is, move current pointer at next equals new record pointer. So here's my new record pointer, right? And here's my current pointer at next. So current pointer at next equals new record pointer. So what happens is both a new record pointer now point to the exact same thing. And this bad boy Rahel now points to null. And now that points to null, right? And then the process repeats itself. But notice what I'm doing is I'm linking all these elements together. And it's important to note, if at any point in time you lose that next, it doesn't point to the right thing, you're actually going to lose the data. And everything's going to come crashing down. Now, we haven't really looked at it, but your display list. All of this is just methods of actually outputting it. But it puts current pointer equal to head pointer, and then has county and population. And all it's doing is it's following the null while current pointer is not equal to null. So it starts at current pointer equal to head pointer. So current pointer and head pointer are now pointing to the same things, right? So now we're going to point over here. So current pointer and head pointer are now pointing to the same thing. Now what it does is, if you look through my code here, it says, all right, I output current pointer at county name and current pointer at population. So whatever the county name and population here it outputs. And then it says, all right, while current pointer is not equal to null. Now, do da 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 da. Notice, see, there's current pointer equals current pointer at next. So now what I do is I take my current pointer and I move it here, and it does the same thing. It repeats this itself once again. Current pointer at county name, sees it out. Current pointer population, sees it out. And then we come back around here, and now we're over here. And then it sees it out again. And now we're over here, and then sees it out again. And then at the point in time when current at next equals null, that's what it's going to stop. And if you look for our delete list, it's very, very similar. It's deleting part of the elements and then pushing them back together. Okay, so that gives you, in a nutshell, the different elements as it references linked list. If you have any questions for me, let me know, but otherwise this is the foundation on which we're going to use everything going forward for the rest of the semester. So make sure that you understand linked lists. Vital, vital, vital. Thank you for your time.